of parallelograms, just generally speaking. This is what you took the quiz on. And the results were okay from the quiz. It wasn't too bad. What is the most basic definition of a parallelogram? Like, why do they call it a parallelogram? What's the most basic property that goes with Shaughnessy? Okay, there you go. Parallelogram, parallel. Yeah, both pairs of opposite sides are parallel. But then in addition to that, there was a few more properties that got tacked onto that. One of the most obvious ones being not only are the both pairs of opposite sides parallel, both pairs of opposite sides are also say it again. Both pairs of opposite sides are? They're also congruent, yeah. So both pairs of opposite sides are parallel. Both pairs of opposite sides are congruent. Then we learned some stuff about the angles. Opposite angles are congruent. Opposite angles are congruent. How about consecutive angles? Doesn't say it there, but they are what? Supplementary. Good. Consecutive angles that are next to each other are supplementary. Diagonals. Diagonals are segments that connect two non-consecutive vertices. They're these segments that cross in the middle. They bisect each other. They cut each other in half. They are not congruent, but they do bisect each other. They cut each other in half. Then we learned some ways to prove, like let's say that you're not sure that you have a parallelogram. You're not being told, you're being asked if you have a parallelogram, right? These are what you could use to prove it. Both pairs of opposite sides are congruent. That would be enough to prove it. Both pairs of opposite angles are congruent. That would be enough to prove. If you're not sure, that would be enough to prove. Diagonals bisect each other. That would be, of the ones that we just named, those three could be used to prove. And then now this is the one that was missed the most on the quiz. There was one that pertained as like a true or false, and it was missed quite a bit. If you have we know that both pairs of opposite sides are parallel. We know that both pairs of opposite sides are congruent. But if they were to tell you that just one pair is both parallel and congruent, even if we know nothing else about that other side, we know it's enough to say that it's a parallelogram. That is enough to prove that it's a parallelogram. But you'd have to have both, right, Bazit? You okay, man? You having a bad morning? You good? Okay. So then, what today's lesson is going to be on is taking everything we already knew about parallelograms, but then now stacking more rules on top of it to develop special parallelograms. One of which is a rectangle. A rectangle takes everything that we already know about parallelograms, everything you took on the quiz before you left, but then adds a few more specific properties. The most basic of which would be that I had it written here. The most basic definition of a rectangle is a parallelogram. Like every rectangle is a parallelogram. Not every parallelogram is a rectangle, but every rectangle is a parallelogram. And so everything on this page takes what we had on the page before. We accept it as being true, but then what we add to it is that all four angles are congruent. There's a few other things that we're going to add. There's a few other properties, but that's the most basic of them. The most basic property for a parallelogram is both pairs of opposite sides are parallel. For a rectangle, it's that all four angles are congruent. And on a quadrilateral, if all four angles are congruent, how much do each of those angles measure? Every quadrilateral has 360 degrees inside of it. 90, yeah. If you divide by 4, you get 90. Okay. But here are some of the other ones that are true for a rectangle. Diagonals. What do we already, because a rectangle is a parallelogram, what do we already know about the diagonals? What's true? What's true about the diagonals of a parallelogram? No, not on a parallelogram. Not that they bisect each other. So that's still going to apply on a rectangle. Because it applies on a parallelogram, it's still going to apply on a rectangle. But in addition to that, yeah, now we're also going to learn that in a rectangle, the diagonals are also congruent. So really, if I were to mark this, I could say that all 4 of those smaller segments, if I were to, let's say I were to name this here point M in the middle, AM is the same as BM, is the same as CM, is the same as DM. Also, BD is the same as AC. They're congruent. Okay. Yeah, so I already covered everything that's here. This is what I thought I had on. I guess I got deleted on the rectangle, where I put it in just plain words. The next special parallelogram is a rhombus. Everything that is true about a parallelogram is also true about a rhombus. Every rhombus is a parallelogram, but not every parallelogram is a rhombus. What's the most basic rule that we're going to add on for rhombuses? Is that now it's not the 4 angles that are congruent. It's the sides that are congruent. A lot of people get this confused with a square, and they go, "Oh yeah, what's a parallelogram with all 4 sides congruent?" And they go, "Oh, it's a square." No, it's not. It's a rhombus. If we know nothing about the angles, then it's a rhombus. But we can add a few other rules. What are some things we know about the here's a big one. The diagonals are not congruent on a rhombus. They're not congruent, but they are. What one word can we use to describe when they meet at 90 degrees? Perpendicular. Yeah, good. The diagonals are perpendicular on a rhombus. Okay. Also, the individual angles, the 4 angles on a rhombus, when you draw the diagonals bisect the angles. So, like if I were to say that this is rhombus A, B, C, D, and I were to tell you that angle D is 50 degrees, once I draw the diagonal, each of these would be 25. Each of the smaller angles would be 25. ADB would be 25. CDB would be 25 if that were 50. And that perpendicular, all sides are congruent. Yeah, that covers everything from a rhombus. Then, if a rectangle and a rhombus were to have a baby, if they were to fall in love one day and start a family, that baby would be a square. What's true about squares? Everything you've learned so far is true about squares. Every square is a rectangle. Every square is a rhombus. Every square is a parallelogram. Every single property that is on the notes before this slide is true about squares. Diagonals are congruent. Diagonals are perpendicular. Diagonals bisect each other. Sides are congruent. Angles are all congruent. Opposite sides parallel. Everything that's on here before it applies to squares. So what I did then is I conveniently placed that for you all on one page. If you're following along on the notes that should be in front of you right now, what are some facts about parallelograms here? Parallelograms, this is what's true about the sides. Parallelograms, this is what's true about the angles. Parallelograms, here's what's true about the diagonals. Now, what you could ignore for right now is what's in blue. Because originally we were told that we were going to have to teach you coordinate geometry with parallelograms, but I guess mostly due to the proximity of the midterm, that the midterm is coming up a lot sooner than maybe we had planned for. We're not going to include that as part of the test on parallelograms you take on Monday. So you can ignore the stuff in blue. You don't need to worry about distance formula, slope formula, midpoint formula. But what's in red still applies. If you work your way down the slide, there's your rhombus, there's for your what's true about squares. What is squares have everything that's on the page above it. Diagonals are perpendicular, diagonals are congruent, diagonals bisect each angle. It's just all put on one page for you. Yeah. So yeah, tomorrow is PSAT or Gateway. I don't know which one applies to you guys. Okay. And it's just in the morning. That's not for my class. That's just a school-wide test. Then when you come back on Thursday here, I have a practice test ready for you. That's what's on the calendar. I have a practice test for you to take on parallelograms. We'll review that test on Friday to get you ready for the real test on Monday. Then we'll spend the rest of next week prepping for the midterm. The midterm is on Friday. Yeah. I gotta ask about that. There's a modified schedule for tomorrow. I know that it's like going up until like 11 something. So, and then there's supposed to be like a modified schedule for the rest of the day because I would assume that affects lunch. But they haven't given us anything in print. So I gotta ask to see if they have published some type of modified schedule for tomorrow. I don't know. All right, so let's go now through the examples because I know we learn better through examples. I already knocked out all the examples for parallelograms, just general parallelograms. So let's do the ones for rectangles, rhombuses, and squares. Okay, tell whether each quadrilateral is a parallelogram, rectangle, rhombus, and square, and give all the names that apply. Okay, so let's look at number 11. I know number 11 looks like a rectangle, but don't go by appearance. Now this shows us though that each segment that goes from the angle to this kind of like midpoint in the middle, those are all the same. Which one did we learn? Right. Yeah, a rectangle. Now they only show me that that one of the angles is 90, but if you want to be sure, we would go over here for rectangles. It doesn't have a proof for rectangles. But that should be enough. 4 angles. 4 right angles. Yeah. Yeah, you know what? I take it back. They don't have to show you. They don't have to show you all 4 because think about it. If this is 90, this has to be 90 as well, right? Because opposite angles are congruent. And then if consecutive angles are supplementary, what do I have to add to 90 to get 180? Also 90, yeah. So, yeah, this is a rectangle. Could it also be a square? No. No, because then all the sides would have to be congruent. Okay. How about 12? I know it looks like a rhombus, but in order to be a rhombus, they'd have to tell me that either all the sides are congruent. They're not giving me any information about the sides. They'd have to tell me that the angles are being bisected. They're not. So what's the only thing that's being told to us by the way that it's being marked? Opposite sides. No, they're not giving me any information about the sides. They're not telling me that the diagonals are congruent. That's why this has one of them has 1 slash, and the other one has 2 slashes. Yeah, that they're being bisected. That's the only thing they're saying, is that the diagonals are bisecting each other. So yeah, I agree. It looks like a rhombus, but we're not going to go by appearance. We're going to go by the markings. So what's the only thing we can say about that? If all we can say is that the diagonals are bisecting each other. A parallelogram, good. Yeah, parallelogram. That's the most specific that we could be. Okay, how about the next one? Looks a lot like a square. It looks a lot like a square. Now, What does that make it? The fact that all the segments from the center to the angles, if all of those are congruent, what does that make it? Yeah, that makes it a rectangle. But the diagonals are also perpendicular. What does that make it? Hi. Okay. I think it would, see if it fits in that back corner there. That would probably be easy to put up there. Oh, you want to, I think I might have thumbtacks. Be careful. What does that make it? The fact that the diagonals are perpendicular. A what? No, the diagonals are not perpendicular on a rectangle. A rhombus, good. A rhombus. And then on any quadrilateral, if a quadrilateral is both a rectangle and a rhombus, then it has to also be a square. Yeah, if it's both of these, then it has to be a square. See, so also pay attention to the directions. See, these directions say give all the names that apply. That's why I wrote all three. But in many cases, what you're going to see is it's going to say give the most specific name. If they only want one name that is the most specific, what's the most specific out of those three? The square, sure, the square. The square would be the most specific. Okay, same directions here. Both sets of opposite sides. I know it looks like a rectangle, but based on the way it's marked, if all I know is that both pairs of opposite sides are congruent, yeah, we only have enough information there to say parallelogram. Because in order to be a rectangle, they'd have to tell me that at least one of those angles is 90. How about the next one? Okay, well, all right, because that one angle is 90, fine, we can say rectangle. But because all the sides are congruent, we could say, rhombus, and then, yeah, and then if we can say rectangle and rhombus, then we have to also be able to say square. If they only ask for one, I would just say square, but they're asking for all again. Okay, look at this next one. Angles are being bisected, so what does that make it? A rhombus. When the diagonal bisects the angles, that makes it a rhombus. Okay. But now, in order to be a square, all the angles have to be congruent because it has to be a rectangle also. It has to be both a rhombus and a rectangle. There is nothing here to indicate that all the angles are congruent. They are telling you that two sides are congruent, even if they were to tell you that all the sides were congruent, well, that would still just make it a rhombus. In order to be a rectangle, you have to also consider the angles. And then, you know what? I'm thinking this through in my head right now. What am I missing? On 3 of the problems, there's one word that's missing. Because if anything is going to be a square, a rectangle, or a rhombus, what else does it have to be? Yeah, it has to be a parallelogram. So again, not because it's more specific, but that should be a parallelogram. This should be a parallelogram. And this should also be a parallelogram. Basically, every single one should be a parallelogram. Just because it says all. It says give all. Okay. Any questions there? Okay. The next example we did already because that was just parallelograms. We did that one already. We did this one already. We did this one already. That was parallelogram. Did all the parallelograms. That one we did that one. Coordinate we're not gonna have to do. Alright, so let's go here. Hey, find that one on your notes. A carpenter measures the diagonals of a piece of wood. They tell you that this is a rectangle. What do we know about the diagonals of a rectangle? They're not perpendicular of a rectangle. Diagonals of a rectangle. I have a nice little reference sheet that I made for you that tells you rectangle, diagonals. They bisect each other, but that just makes it a parallelogram. Diagonals bisecting each other is listed for every single one of them. What's more specific about a rectangle? Yeah, they're also congruent. That's listed there too. So we make it back here, and they tell us that JM. It might be hard to see on your paper, but JM is down here. That's going to be 25 inches. That's a side. That's not a diagonal. And JP, which is half of a diagonal, that's 14 and a half. I'll just put 14.5. And find each length, okay? So they want us to find JL. JL is an entire diagonal. How would I find JL? Yeah, or you can do 14.5 plus 14.5. Yep. Either way, 14.5 times 2 should be 29. 29 inches. How about KL? KL is a side. Because a rectangle is a parallelogram, opposite sides are congruent. Yeah, that's going to be 25 also. So it's congruent. Anything else? 12 KM. KM is the other diagonal. Diagonals are congruent. That would also be 29 because I already knew that the other diagonal was 29. And then 13 MP is the other half of the diagonal, which is still going to be 14.5 because all the little halves of the diagonal. Angles of a rectangle. What do we know about angles of a rectangle? They're congruent, and because we know that in any quadrilateral, the angles add up to 360, not only do we know that they're congruent, but specifically, what is the angle measure of all the angles of a rectangle? 90, yeah, they're each going to be 90. Now, what happens is when you get a quadrilateral and you draw a diagonal, what new polygon is created? When you draw a diagonal, what new shape is created? A triangle, yeah. And what do we know about the angles of a triangle? Yeah, they add up to 180. So you have to keep that in mind as well. So here, let's do 18. Measure of angle 1, measure of angle 2, measure of angle 3, measure of angle 4, measure of angle 5. Which ones there would you say would be the easiest ones to find if you know there's a rectangle on number 18? Okay, let me rephrase. Let me take out easy. How about the quickest? What would you say would be the quickest ones to find? Hell, I would say 3 and 5. I mean, because what are 3 and 5? Yeah, those are right angles. Those are the actual angles of the rectangle. Those are the 90 degrees. There's no work needed there. Okay. Now, how would I find the next one? I would find would probably be 4. I would say. There I could do 90 minus 61. 29, you said? Yeah. Now, 1 and 2, there's a couple ways you could do it. If I know that 4 is 29 and I know that 3 is 90, well, yeah, you can use the interior angle sum of a triangle. You also learn the corollary that says on a right triangle, when a triangle is right, the two other angles that are not the right angle are complementary. Yeah, it ends up being 61. If you wanted to be super clever, because a rectangle is a type of parallelogram, both pairs of opposite sides are parallel. 1 and 4 and the 2 and the 61, those are alternate interior. What do we know about alternate interior angles? Yeah, they're congruent. So really, angle 2 is the same thing as the 61. And then angle 1 is the same thing as 4, which was 29. Let's do this next one. Measure of angle 1, measure of angle 2, measure of angle 3, measure of angle 4, measure of angle 5. Remember, even though that looks like a square, all we know for sure is that that's a rectangle. Okay. Okay. What would be the first one you would find there? 2? I would say 1, because this one's a little trickier here. So I would go with 1, because at least 1, you know, is going to be complementary with the 36. Because if this is 90, then 36 at angle 1 have to add up to 90 also. So 90 minus 36 is 50. Okay, so now that we know that 1 is 54, we know that 4 and 5 make a linear pair. Can we use exterior angle sum on any of these? This is going to be the same as angle 3 because they're alternate interior. This is going to be the same as angle 1 because they're alternate interior. This is going to be the same as angle 2 because they're alternate interior. This is the same as 4 because they're vertical. This is the same as 5 because they're vertical. This is 36 because they're alternate interior, 36 degrees. And if I know that angle 1 is 54, this is 54 degrees here. So I'm trying to see what could I have enough information. Also 54 degrees. Wouldn't that make what? Oh, you know what? But do you know why? Do you know why? No. What type of new polygon is created? No, come on, look at the inside. What do you see on the inside? What are all these little shapes on the inside? Yeah, the triangles, right? But guess what? Because I'm a rectangle, all those are congruent. What type of triangle? Isosceles. All those are isosceles. And then the base angles are congruent. So very good. That's exactly. So then 2 has to be 36. 3 has to be 54 degrees. And then 4 and 5, you would just take those away. So 36 and 54 is 90. So that means that so yeah, 5 and 4 would have to be 90 then also. Actually, no, I take it back. I take it back. No, just kidding. No, sorry. That's not true. So, because if 3 is 54, 54 and 54 is 108. So 5 would be 180 minus 108. So that would be 72. And then since 4 and 5, see, because if this is 54 and 54, then for 5 here, the only thing left is 72 degrees. And then since 4 and 5 make a linear pair, I can just do 180 minus 72, and that gives me 108. You could have also actually used exterior angle sum to find 4 and 5. Just because we're low on time, let me skip to rhombus. What do we know about a rhombus? That the diagonals bisect the angles. So if they told us that this is a rhombus, the angles of a rhombus five we can find out right away. How much is 5? 27. Yeah, 27. And then kind of the same thing, we were clever about this because on a rhombus all the sides are equal. That makes those two triangles isosceles. So not only is 5 going to be 27, 3 has to also be 27. 2 has to be 27 degrees. And then 1 and 4, you would just take whatever is left over. 27 and 27 is 54. So 180 minus 54 is 126. And that would be 1 also. Let's do one more with a rhombus. If they're telling us that this is a rhombus already. Well, because a rhombus is a type of parallelogram, opposite angles are congruent. So that would make angle 470. I know that. And then because these are the smaller triangles are isosceles, if this is called the vertex angle is 70, how many degrees do 1 and 2 have left to split to share evenly? 110, yeah, because on a triangle there's only 180. So then angle 1 would be 110 divided by 2, which is 55. And really what ends up happening is that all of these end up being 55 because 4 was also 70 degrees. Let me see if I can do coordinate. Hold on. If you want, see if you can do these on your own, and then tomorrow I'll be here before school, before 7. I have to go to my testing thing at 7. So if you want to practice any of these before 7, let me know. Come by.